Image formation by concave mirror 2. Objective: to study the image formation by concave mirrors. Let us use a ray diagram and mirrors formula to identify the position of the image when a point object is placed either on the center or after it. First, let the object be placed at the center of curvature of the concave mirror. One ray passes and gets reflected along the principal axis. Consider another ray incident on the mirror at point A. Second ray traces its path backwards after reflection. Two rays meet at the center of curvature. Hence, a real image is formed at the center only if the object is kept at the center. We can get the same result using mirror's formula. Distance of the center from the pole is double that of focus. Substitute u equals to minus 2 f naught and f equals to minus f naught in the mirror formula. We get v equals to minus 2 f naught. This suggests that a real image is formed only at the center. Now let the object be placed between C and F. One ray passes and gets reflected along the principal axis. Another ray that is incident on the mirror gets reflected and meets the first ray at a point that lies beyond C. Hence, if the object is placed between C and F, a real image is formed beyond C. For example, let the object be placed at a distance that is 1.5 times the focal length. Substitute u equals to minus 1.5 f naught and f equals to minus f naught in the mirror formula. V comes out to be minus 3 f naught. Clearly, a real image is formed beyond the center of curvature. Now, let us place the object at the focal point. One ray passes and gets reflected along the principal axis. Another ray that is incident on the mirror becomes parallel to the principal axis. The two rays tend to meet at infinity. Hence, a real image is formed at the infinity if the object is placed at the focus. If we substitute u with minus f naught and f with minus f naught in the mirror formula, we get v equals to minus infinity. This is the same result as we got from the ray diagram analysis. Now let us look at the case in which the object is kept between the focus and the pole P of the mirror. A ray passes and gets reflected along the principal axis, while any other ray gets reflected and diverges away. This ray does not meet the principal axis. If we extend both the reflected rays, the rays seem to come from a point that lies on the other side of the mirror. Hence, a virtual image is formed if the object is placed between the focal point and the pole. We get the same result when we substitute u equals to minus u naught and f equals to f naught in the mirror formula for the concave mirror. Here, f naught is greater than u naught. So, a virtual image is formed behind the mirror. For example, let the object be placed at a distance that is 0.5 times the focal length. Substitute u equals to minus 0.5 f0 and f equals to minus f0 in the formula. V comes out to be f0. Clearly, a virtual image is formed.